In the following movie, we'll create a solid model from the deformed shape of a finite element analysis. Here you can see we have a finite element model created with boundary conditions and loads. There's a load in the z direction on the right end of the beam, and it's fixed on the left. We'll begin in post-processing setting the deformation to scale to 1 absolute. So we're looking at the absolute scale of the deformation. This will be important in identifying results, which is the next step, and writing it out to a file. Here we'll give the file a name. We'll start with the undeformed model. And all we need are the x, y, and z coordinates of the model. We'll turn off right column header as well, because that will not be needed for the global deformation command, which we'll do in a minute. Next, we'll write out the deformed CSV file. And here, that's as easy as toggling on the right deformed coordinates. And there it will select whatever deformed scale we had set, which was 1 absolute, which is what we want for creating our deformed model. Now that we've written out those 2 CSV files, we're ready to go back to our CAD model, which currently is undeformed. And we need to extract the faces of the solid body in order to create a sewn sheet body. So we'll begin by extracting those 6 faces and then sewing them into a sheet body and making sure that our modeling preferences were set to create a sheet body. Next, we're ready to go into the global deformation command now that we've prepared the model completely. So there we'll select our sewn sheet body, and we'll select our undeformed points file. For our product shape, here we can show the points and see that they lie right on the model. Then next we'll select our deformed or reference shape, and here you can see those points as well, deforming upward. There are a number of different options for the settings where we can adjust the accuracy of the deformed shape with the grid size. Here we'll leave it at the default, which is 3. And you can see that the model is sprung upwards. If we choose compensated instead, this creates a deformed shape in the opposite direction. So here, if we leave the grid size at 3, you can see a slight mismatch on the boundary condition. If we bump that up to 6, that mismatch becomes less. And that concludes the presentation on creating a deformed model from FE results.